Hello calculus friends. This video I'm going to review basic derivative skills. This is intended for people that are going into Calculus 2, Calculus 3 that just need a little refresher, have seen derivatives before. So I'm just going to say a few general things I always say, but give a little more detail than I would in class. These things I'm showing you here, this is from some of my review materials. So if you do a Google search for Andy Lovelace, of all the Andy Lovelaces in the world, I have the biggest website, but probably your best bet is to click on Math 125 materials, and there's two things on the right. Calc 1 review, which has kind of the basic reminders about those skills, and then the exponent rules. Those two things are really your key to knowing your derivatives. But let me just say a few general things and then do some problems. So first off, you have to know the collection of rules. I'm not going to talk about where they come from. That's for a different discussion. But the main rule is polynomials, things with powers like this. The number comes down, it goes down 1. And this represents the slope, but that's a whole, I'm not going into that. Exponential functions. The general rule, I don't have it written here, but let's write it now. A to the x is a to the x times log of a. The best thing to have in place, the best number to have in place of a is the symbol e, because log of e is 1, and so it gives you the nice. So that's why we typically, if possible, use e, but that's the more general rule. And then we have 6 trig functions. Now I always represent them this way. This is my goofy thing I call the Lovelace law of the C's. If you have a trig function that starts with a c, then there's a negative here. It's just a goofy way to remember it. I call it the Lovelace law of the C's, like I'm a pirate or something. But that's those ones. So at some point you want to commit these to memory because they're all going to come up throughout Calculus 2 and 3. So just remember the derivative sine is cosine. Derivative cosine is negative sine. I mean, you can think in terms of slope, but that's another thing. Tangent is secant squared. It'd be good to just put these somewhere so you looked at them every time you open your notebook. Inverse trig, I would argue that they don't come up that often, and when they do, most often you see arctangent. And this means inverse, so arc sine of x is the same as this, which is not the same as sine of x to the negative 1. That's a totally different thing. It's an unfortunate bit of notation. Because this would be 1 over sine, which is not the same thing. Okay, then there's 3 combination rules, which is the product rule, the quotient rule, and the chain rule. So when I'm teaching students derivatives, I talk about if you just have a single term, meaning you have something, 3 halves x to the 5th, just one term, something that's completely, so if you have more terms would be, a term is something completely separated by pluses and minuses. So here I would have, let's not get into too many details. I want this to be accessible. Here's an expression that has 3 terms. So when it comes to derivatives, the first rule is this means you have 3 different derivatives to do. So sometimes I say the plus just comes along for the ride. Pluses and minuses come along for the ride. The next rule is coefficients. This is a coefficient, this is a coefficient, this is a coefficient. Coefficients just come along for the ride. Then your job is using the rules here on these pieces. And if it's a polynomial, your first step is to rewrite the exponent rules. And if that's the part that's holding you up, I have an easy place to practice that in my exponent rule sheet. This is just a reminder of how fractions, this is the common errors I see from students. And it's little things like 3x. These are the things that hold students back. 3x squared over 4 is the same as 3/4 x squared. You got to get really comfortable with moving numbers around, right? So if this is a challenge to you, this is a side thing that will never go away. I made this just so you could practice. So for each of these, they're all examples of one term. I guess you could call this 2 terms, but it's really just fractions. But things where, can you write it the way a calculus student would write it so they can use their rules? So you can try that on your own. The calculus student would write this as 2x to the negative 7. A calculus student would write this as 1/3 times x to the 16. You can play this game and see that you're comfortable and then see the answers here. That's step one, is you need to know those, be able to rewrite terms. Okay, so now let's go to an example here. And this is something I do in the first lecture of my Math 125 course. I just thought I'd make a video and do it in more detail. So let's just talk about them one at a time. This first function has 3 terms. 1, 2, 3. And for some people this is going to be too slow, but this is an opportunity for me to go in a little more detail. So that means I have 3 jobs. For each one of those, I'm going to rewrite the term. So I'm going to rewrite each term in a way, because I would argue that it looks kind of pretty right now. I'm going to write it in an ugly way. This is 7, and if you're having trouble with this, 7 over x to the 10th is the same as 7 times 1 over x to the 10th, which is the same as 7x to the negative. If you want to be good at calculus, you got to be able to do those things quickly. So that's step 1. That's the first term. The second term, so square root is the same as 1/2 power x to the 3/2. And then the last term, that's often the stumbling block in my experience. It's just rewriting it the way a calculus student write it. Why does a calculus student write it this way? So they can use those rules. So there's 3 terms. Each term is one of the basic forms, so I'm done. What do? The pluses and minuses come along for the ride. The coefficients come along for the ride. And then I just use the derivative rules. And those are all in our list of derivatives. So the power comes down. This is going to be negative. And I would do this. Always make sure the power goes down. You're subtracting 1. Power comes out. And it goes down 1. So it's going to be half. And the derivative of this is 1 over x. Now, you can do that in one step and clean it up. You know, sometimes I say, if you're going to do more, then maybe you want to become an algebra student again and write it in a prettier way. That's a matter of taste, how you want to write it. I personally, if I was doing this problem, I might rewrite it as 70 over x to the 11 minus 15/2 square root of x plus 4 over x. But that's just a matter of taste. So there we go. So let's go to the next one. Problem 2. It's 3 terms. This one right here is a constant term. There are no x's. And if there are no x's, the derivative is 0. It's just a number, 3.14. Okay, so let's write this function down. The function is e to the 6x plus 5 arctangent of x plus pi. So I have 3 terms. The sums come along for the ride. The derivative of the constant is 0. The coefficients come down. And now I'm down to these 2 jobs. Now arctangent was in the list of derivatives we know, so we can write that down. This one is not in the list of derivatives we know. So if you go back and look, we know e to the x, but we don't know e to the 6x. But what do? This is when so if it doesn't fit the basic rules, then you're going to be saying product, quotient, or chain. This is a chain rule problem. You're going to do the derivative of the outside, and chain rule is something you do all the time, so you need to be comfortable with this, times the derivative of the inside. And the way it works is you write the derivative of the outside, which is e to the x, but you leave the inside as it was, times the derivative of the inside, which is 6. So there's your quick chain rule. And if I was going to write this prettier, I would write 6 e to the 6x. And I want you don't need to write every excruciating detail. This video is just a quick review of some of these things. Last one, so h of x, I'll write it down here. H of x is x to the, I think I said, 3rd cosine of 4x plus the log of 2. So I see 2 terms. Notice there is no x here. So the derivative of that is 0. Log of 2 is just a number. So the question is, what about this term? This term is different because it has multiple x's. There's an x here, and there's an x here. When you have one term that has multiple x's, then you got to think product, quotient, or chain. That's how we think about it. So product, quotient, or chain. In this case, it's a product. There is no fraction there. Sorry, I erased that. That's a 3. So you're going to do product. And I label this is the first, this is the second. We just start doing the product rule. First times the second plus the derivative of the first times the second. And you just start filling them in. The first is x to the third. Sometimes I even just leave space. The second is cosine of 4x. So that's what that is. That's what that is. Now we do the derivative of the second and the derivative of the first. The derivative of the first is 3x squared. So what needs to be done is I need the derivative of the second. So first you have to think, what is the derivative of cosine? And another way to think of the chain rule is this. Pretend you're walking up to the function. The first thing you encounter is the c. So your first job is to take whatever the derivative of cosine is. The derivative of cosine, remember the loveless law of the c's, is negative sine. So the next thing you do when you're taking the derivative of this is you write negative sine. And then the thing you put in here is the same as whatever it was, and that's step 1 of this chain, of the chain rule. Then you erase that and you keep walking. The next thing you encounter is 4x, the derivative is 4. If I was going to write that here, I'd write negative 4 sine of 4x times x to the third. I probably would just squish all that together in a way that looks pleasing. X to the third sine of 4x plus, sorry, I got kind of messy there, but I'm trying to focus on explaining. If you need more practice with this, so you can see the skills. The skills are knowing how to rewrite a given term, and then using the known rules. If you go to my Math 124 materials, you can see lots of places where you can practice derivative, a list of random derivatives. Now, some of these derivatives are overkill, like logarithmic differentiation, but some are fairly quick. Like this one's a logarithm, you can skip that one. But I have full solutions to this. These should be really fast. There's a chain rule. There's a chain rule. This is just more about a pattern. This is implicit, which we won't really do. There's just a straightforward one. There's a quotient rule. So if you need practice, it's there. I don't think you need to go back and practice. The point of this video was just to give you a quick refresher of the ideas. Separate your terms. Rewrite each term if necessary. And then for each term, is it one we know, or we do product, quotient, or chain? All right, hope that helps.